This question says, use the properties of logarithms to rewrite the expression as a single logarithm. Wherever possible, evaluate the logarithmic expressions. So the properties that we're talking about, properties of logarithms, are the product, quotient, and power rule. The product can be turned into a sum, the quotient, subtraction, and when we have a power inside the log, the power can come out. Now this question is kind of going in reverse of those, starting out with an expanded log and making it condense to a single log. So if we have a sum of two individual logs, that's going to become a product inside the log. If we have a difference of logs, that's going to become a quotient. And if we have a number out front, that number out front can be moved to become the power inside the log. So let's take a look at the question that we have. We have natural log square root x minus 1/3 natural log x plus natural log 6th root of x. So when we start to try to condense this, the first thing we want to do is handle the power rule. If there are any numbers out front, we need to move those numbers out front to become powers. You're not able to use the product rule or the quotient rule when you have coefficients. You notice that none of the expressions I have next to the product rule or quotient rule have a coefficient on these numbers. So we have to take care of the power rule first. So the first thing I'm going to do is move that 1/3 power into the exponent. Okay. On the other two expressions, natural log square root x, I want to rewrite the square root as the 1/2 power, and I want to rewrite the 6th root as the 1/6 power. That makes all of the expressions in exponential form. So I've taken care of that power rule with the power out front. Okay, the power rule moved that 1/3 to the power. And I've also changed the radical square root to 1/2, the 6th root to 1/6. Now that I don't have any more coefficients on the logs, I can use the product and quotient rule to condense to a single log. All of these are natural logs, so that's the log I'll condense to. And inside that log, you're either going to have products or quotients, and sometimes you might have both. So we notice that this log and this log are both positive, but this log is negative. So the two logs that are positive are going to be multiplied and put in the numerator, and the log that's negative is going to go into the denominator. So that's using the product and the quotient rule at the same time. So we have natural log x to the 1/2 times x to the 1/6 over x to the 1/3. Now in this example, because all of our bases on these exponents are x, we're able to combine these together into a single factor. So we're now going to be using the product rule and the quotient rule, but this time it is the product and quotient rule for exponents. So the product rule for exponents says that if you have x to the n power times x to the m power, you're going to add those exponents. So for example, if you had x cubed times x squared, that's x to the 5th power. You're multiplying expressions with the same base, so you add those exponents together. The quotient rule for exponents is when you have x to the n over x to the m, So you're dividing expressions with the same base, so you're going to subtract those exponents. So that's what we're going to do with our example here. We have x to the 1/2 power times x to the 1/6 power. They have the same base and they're being multiplied, so we'll add those exponents together. Then we're dividing by x to the 1/3, and we'll subtract the 1/3. So let me erase this so I have some room to work. So now I'm going to combine these together. 1/2 plus 1/6 minus 1/3. I need to get a common denominator to add those together. The common denominator is going to be 6, so that becomes 3/6. 3/6 is the same thing as 1/2. And then minus 2/6. 2/6 is the same thing as 1/3. All the bases are the same. You can combine the numerators. 3 plus 1 is 4, minus 2 is 2, so I have 2/6, and that reduces down to 1/3.